Good evening, dear student. You are all welcome to our YouTube channel. In this class, we are going to discuss about the first chapter of class 9 mathematics. So in last class, we had discussed up to exercise 1.1. Now in this class, we are going to discuss about the exercise 1.3. So before move on to the exercise, you can see there are two special cases in the page number 10. These are case 1, the remainder becomes 0. You can see in the example of 7 by 8, we found that the remainder becomes 0 after some steps, and the decimal expansions of 7 by 8 is equal to 0.875. Other examples are half is equal to 0.5. 639 divided by 250 is equal to 2.556. In all these cases, the decimal expansions terminates or ends after a finite number of steps. We call the decimal expansions of such numbers terminating. So it means if you divide a number by another number and after some finite steps, if you get 0 as remainder, then the decimal expansion will be terminating. This word terminating you have to keep in your mind. This will be needed in the very beginning of the exercise 1.3. In next case, the remainder never becomes 0. In the examples of 1 by 3 and 1 by 7, we notice that the remainder repeat after a certain stage, forcing the decimal expansions to go on for even. In other words, we have a repeating block of digits in question. We say that this expansion is non-terminating. Another term which you have to hold on your mind, that is non-terminating. It means if you divide a number by another number and if you are unable to get 0 as remainder, then the decimal expansion will be non-terminating. Now move to example. Let's see an example. Suppose example 7. You can see here, show that 0.3333 dot dot is equal to 0.3 bar. So it can be expressed in the form P by Q, where P and Q are integers and Q not is equal to 0. So there is a solution, but I think we should not follow this solution. So let me do in my own way. Let's see here. So first of all, look at this question. So bar is stand on only one digit. So both sides will be divided by 10. You can solve this way. Let x is equal to 0.33 dot dot. Suppose you can add another, you can add more digits here. Let me try another one. Let x is equal to 0.3333 dot. So you can see in the question here, so bar is stand on only one digit, so you have to multiply both sides by 10. So it is 10x and it is 10 into 0.33 dot dot. It is 10x remain as same, and if you multiply this right hand side by 10, then this decimal will be moved to right hand side to one digit. So it's 3.333 dot dot. So 10x is equal to, now you can write this 3.333 as 3 plus 0.3333 this way, and then it is 10x and it is 3 remain as same, and this part 0.3333 you can see in the beginning it's equal to x, so instead of this part we can put x. Next part, ten x, another x which was in right hand side turn to left hand side, it will be minus, is equal to 3. Now it is 9x is equal to 3x. This 9 move to right hand side and it will be divided 3 by 9. If you divide this term fraction by 3, then you will get 1 by 3. So this is 1 by 3, which you have expressed in the p by q form. That is the solution of this example 7. Now move to exercise 1.3. In the first question you can see here, write the following in decimal form and say what kind of decimal expansion each has. So here are some fractions, so you have to identify what type of decimal expansions is this or are these. So number 1, suppose here 36 by 100, so is equal to 0.3. so if you divide 36 by 100, then after 2 steps you will have 0 as remainder. So if since 0 since 0 is the remainder, then you can say that its decimal expansion is terminating. It is terminating. So another example, suppose this one, suppose number 3, it is a mixed fraction. If you turn this 2 into fraction, then you will get 33 by 8. In this case you have to divide 33 by 8, and let's see what is the result. 33 is divided by 8, not this way but this way. 33 is divided by 8, it is 4 times 32, remainder 1. You have put a decimal here, then it is 10. So 1 time it is 8, again 2, 20, it is again 2 times 16, again 4, 40, it is 5 times. So 40 minus 40 is equal to 0. So now remainder is 0. In this case also you have found remainder as 0. So decimal expansion of this question number 3 will be terminating. Next, suppose this one, I mean question number 5, 2 by 11. So 2 will be divided by 11 in this case. Let's do it. 2, 11. 0 point 2 will be divided by 11, so it is 0 point, so it is 20 now. 1 time 11, so it is 9. So 0 is 90 now, 8 times, so 88. 2, now it is 20, it's 1 time again 11, so it is 9 again. So you can see here 9 again we have found. So this 81 will be repeated again and again. Okay, so we can say decimal expansion of this question number 5 is non-terminating. Non-terminating. So non-terminating. Now move to question number 2 here. You can see in question number 2, you know that 1 by 7 is equal to 0 0.142857, but can you predict that what the decimal expansions of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7? Okay, so you can see, you can write this 2 by 7 suppose as 2 by 2 by 7, suppose you can write it as 2 into 1 by 7. So 2 into, and value of 1 by 7 is 0 0.14285 bar. So if you multiply this uh, term by this 2, then you will get an answer. Suppose that is 2 into 7 14, remainder 1, 2 into 5 10 11, again remainder 1, 2 into 8 16 17, now remainder again 1, 2 into 2 4, and remainder remain 1 5, 2 into 4 8, and 2 into 1 2, 0 0.285714. So it will also have bar. Okay, so now you can say that this 2 by 7 is equal to this one. So like that, suppose 3 by 7, then it is 3 into 1 by 7, it will be also 3. So this part will be multiplied by 3. Okay, and if 1 by 4, then it will be 4. It also will be 4, it is 4. So now this part will be multiplied by 4, you will get another answer. This way you can solve this question number 2. Again, so I am going to solve this problem. So let it is same as example 7. X is equal to 0 0.666 dot dot. So since bar is stand on only one digit, so both sides will be multiplied by 10, 0 0.666 dot dot. So it is 10x will remain same. So since this part is multiplied by 10, so this decimal will move to right hand side. So 6.666 dot dot. So this 10x will remain same again. So in this part we can write as 6 plus 0 0.66 dot dot. So it is 10x is equal to 6 plus. So you can see this part is equal to this part, which is equal to x. So instead of this part we can put x. So I am going to erase this, note it. So 10x is equal to 6 plus x. So 10x remains same. In the earlier line, x was in the right hand side, that x should be turned into left hand side and will be minus is equal to 6 here. 10x minus x is equal to 6. So it is 9x is equal to 6. So x is equal to 6 by 9. If we divide this fraction by 3, then we will get 2 by 3, which we have expressed in the p by q form. So it is the solution of question number 1. Again, suppose this one, you can see, though this decimal, after decimal there are 2 digits, but bar is stand on only 1 digit. So this also will be in this case both sides will be multiplied by 10 as well. So I will not do this. You can try yourself. It's 2 number and this 3 number. In the 3 number you can see that, so after decimal there are 3 digits, and this bar is stand only on both this all these 3 digits. So in this case both sides will be multiplied by 1000, by 1000. You can try yourself. Next, question number 4, you can see here, express 0.9999 dot dot is equal to in the form p by q, and in the second part, are you surprised by your answer with your teacher and classmates discuss why answer makes sense. So in the exam, if this question is arise, then you will not have asked, or they will not ask you this second part only, they will ask you only this first part. This first part, if you minimize, as you will find 0 point, sorry, 0.9 bar. So you can see bar is stand only on one digit. In this case also both sides will be multiplied by 10. It is also same as example 7. Now 5 number, I think it is not so important. So you can see in the 8 number, find 3 different irrational numbers between the rational numbers 5 by 7 and 7 by 8. If you divide this 5 by 7, then you will get a decimal number, and like that in this case also. Let me do this. You can try this yourself, and this screen is not sufficient. This screen does not have sufficient space, so I am unable to do this. So but I can summarize this as 5 by 7. Here you can see it equal to 0 0.71428 this will be repeat again and again. So bar will be stand on this 71428 and like that. If you divide 9 by 11, then you will get 0 0.81818181 this way. So bar will stand on this 2 digits, since the 2 digits repeats again and again. But this question is that find 3 different irrational numbers between the rational numbers 5 by 7 and 9 by 11. So you can write any irrational numbers between these two rational numbers, as suppose this one. Just you have to put which is 0 point, which is more than 0.71 and but less than 0.81. As suppose example 1 is 0.73. You can put any digits after this 3, suppose 4 1 3, this way you have to hold a bar. Another one, suppose 0.77, suppose 2 3 2 4, this way you have to put bar again. And another one, suppose final one 0.89, sorry 79, and something else after this 9, and also you have to put bar on this. So this 3 1 2 3, this will lie, this will lie between this 5 by 7 and 9 by 11. Okay, now question number 9, you can see classify the following numbers as rational or irrational. You have to classify these problems as irrational and irrational. Look at this screen. First one is root over 23, which is irrational. and this second one you can see this one. So second one, though there is a root over 2 to 5, you can write this 15 square and root cancel, is equal to 15, which is rational. Next one, this one. So you can see there is no bar after that on the digits after decimals. So finally so in this case, or if we remove this decimal, you can see here we can write this as equal to 0 for equal to 3796 divided by 10,000. So which is a rational number. So it is also 3 number also rational. And number 4, you can see there is a dot dot. That means the remainder never become 0. So it is irrational. Number 4, irrational. And number 5 also, you can see that after decimal 10 100 4 times 1 and dot 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 dot. So it is also rational, since remainder never become 0 or non-terminating. It is also irrational. That's it. So this is the conclusion of this class. In next class we will discuss on some another topics. So it will be continued. So sufficient for today. So thank you.